The Alberta Council of Technologies presents feature keynote Bilal Khan of Capgemini, May 13th at 7:15. Watch live at bestofanalytics.com. Bilal has over 12 years of extensive experience in the architecture and delivery of programs involving big data, business intelligence, and predictive analytics, ranging from pre-sales activities, project architecture, solution design, to project delivery, as well as key functional and technical SME roles. His business transformational experience in the North American market ranges from the delivery of a $7.8 million program to involvement in programs exceeding $68 million Canadian. Bilal has successfully managed and delivered projects in both private and public sector, including business acquisitions, transformations, SAP Greenfield implementation, systems integration, single instance consolidation, SAP upgrades, master data migration and conversion, web projects, analytics, business intelligence reporting, identity management, strategy and middleware implementations. These projects have been delivered through various combinations of direct reports, third-party vendors, and contractors in Canada, the USA, India, China, and the Philippines. Bilal also brings extensive SAP thought leadership in the areas of SAP Business Analytics with emphasis on master data management, HANA, financial budgeting, planning and consolidation, as well as business objects reporting. These capabilities have been represented at SAP Tech Ed, the SAP HANA Run Better Conference, and as an IBM guest speaker through SAP Code Excellence IBM.
Hi, everyone. Thanks for coming out tonight. Thank you very much for the warm welcome, Donna. So before we begin, one of the things I wanted to talk about was I want this session to be interactive and very engaging. So there will be points in this discussion where I'll connect with you guys and ask you for your feedback, and then we'll go through the entire process of talking about the evolution of human intelligence, big data, and predictive analytics, and storyboarding how all of that comes together to help us make better decisions. Just some quick highlights about myself. Most of this was already covered, but my area of specialty has been primarily from a solutions architecture perspective, mostly on master data management, business analytics, business planning and consolidation, as well as reporting in business objects, and that includes advanced analysis as well. I've also authored a white paper on BW and business analytics it's referred to as a BI Framework 7.0. So before we continue, I wanted to emphasize what some of the key objectives of this presentation are going to be about. In tonight's session, I want to make sure that we have the opportunity to better understand what we mean by human intelligence. What are some of the definitions of human intelligence? How do we measure human intelligence? And when we talk about human intelligence, how has that concept evolved from where we were when we first showed up on this earth to where we are now? And how does all of that tie together to help us with regards to our big data problems as well as business analytics? Is it something that's strictly a technological problem, or is it a problem that's associated with our ability to absorb that information? We'll also talk about what is big data, some of the challenges facing big data in modern economies. We'll talk about predictive analytics. So with all the problems that we face with regards to big data and all the challenges that we face, how can we leverage predictive analytics as a solution to harnessing the power and the capability of big data? And we will talk about some success stories in the market where we have actually been able to apply predictive analytics in solving industry problems. And again, we'll put all of that together and we will talk about how that forms an advantage to Alberta's economy. So let's put our thinking caps on. What is meant by human intelligence? Any takers? Adrian? Okay, so what we will do is we will go through what I call the F test. Psychologist out of the United Kingdom, he put this basic test together, which really helps us. It's his view on how you can capture the intelligence coming out of a community or a group, but his viewpoint on it is that intelligence is more defined as one's ability to perceive information. So I'm going to pull out a sentence here, and you guys, give you 5 seconds. Count the number of Fs, okay? You can't count backwards, so just read forward and count the number of Fs. You have 5 seconds. Okay. So, can anyone tell me how many Fs you guys were able to count? We'll take a count of 3. So,
Placing bets?
sure. How about yourself? How many Fs did you count?
I saw
3. Okay. Any more? 2? 4? 5? Okay. Okay. So based on David Brown's definition of what intelligence was and how to be able to predict one's intelligence based on perception, you know, he came up with the following scale. So if you counted 6 Fs, which is the correct answer, it's highly intelligent, and so forth. So the correct answer was 6. Okay. There are a few definitions throughout history. So some have defined it as the abstract ability to think, capacity for knowledge and knowledge possessed, the capacity to learn from experience. So from our past experiences, what can we learn and how can we analyze that data? The ability to adapt to an environment, as well as the ability to solve problems and create products that are valued within our cultural settings. My favorite definition is the one that I've referred to, which is it's the general reasoning ability that we have based on, you know, our thoughts, our perception. It's the cognitive capability that comes together with functions such as our memory, our communication, right? So intelligence really, depending on who you speak to in the marketplace, in the industry, can have various definitions. Let's talk about human intelligence. So if we go back, Stone Age, human beings, when we first started forming societies and communities, we were gatherers. We were out there gathering information. We were gathering food. We were gathering what we could from the forests in terms of anything that we could to supplement our nutritional needs. The Athenian man was the era where we actually had the ability to harness agriculture. And a lot of that did come from the Middle East and from the Mediterranean. Where we are today, some people may say, well, we're a couch potato man or Homer Simpson man. The problem that we're trying to address here is that there has been so much data out there. And, you know, technology has made our life so easy that sometimes we forget how to use the very basic utilities that exist out there. Like, let's be honest. I mean, how many of us actually understand all the capabilities that exist in our remote controls or in our computers, right? And then, of course, there's the current generation and the future generation where we can actually leverage technology, we can actually leverage data and the software that exists out there to help us make better decisions. Okay? So what is big data? The term big data, I mean, it's a buzzword. When we talk about big data, you know, sometimes people make the mistake of associating big data strictly with technology. Big data is not just about technology. Big data is about all the information that exists out there and our ability to gather that information and turn it into something meaningful. So the 3 V's that we use to define big data are really the volume, the velocity, and the variety of the data itself. Okay? So in Alberta in itself, I mean, people in Canada and usually around the world, I mean, the Australians associate Alberta with hiking or skiing or a place to enjoy their winters. But Alberta in itself has major industries, including agriculture, energy, forestry, finance and banking, and manufacturing as well. So in all of these areas, when you think about it, when you stop for a second and you think about it, you say, well, how does big data apply to all of these areas? If we take a look at agriculture, if we had the opportunity to gather all the live feeds and all the relevant information that came from the agricultural history, weather trends, the crop conditions, the soil conditions, insects, good or bad, as well as pesticides, you know, we would be able to better understand and predict future outcomes of the crop growth in certain areas. Same with energy for oil and gas. So what I'll do is I'll kind of pull out the section for oil and gas. You know, when we talk about big data in oil and gas or in the energy sector, we look explicitly at data that is coming from the drill bits that are like in the upstream process when we're drilling, all the information that is being fed in. We look at exploration information. We look at production data, trading costs, compliance as well. So all of these serve as inputs. They're raw data that serve as inputs into the process. But then again, that raw data is still just data. It's not something that we've turned into anything that is of benefit to us. And putting that data together can provide a lot more benefit than just looking at it in a solid fashion. Now, the data itself can be broken down into, again, the velocity, the variety, and the value. And the value of putting all the data together basically allows us to, know where we should be drilling. What is the right time to invest in an oil patch, right? I mean, there are a lot of companies like PetroChina that have bought oil sands in the north. Like PetroChina, I think they spent $5 billion in the last couple of years. But what is the right time to develop it? And a lot of that really depends on what the right market conditions are. It depends on labor costs, right? It depends on what we're going to get for heavy crude by the barrel, right? So what are some of the challenges facing big data? Again, big data exists. There's a lot of information out there. We have the technology to be able to harness that data. But what are some of the challenges? The challenges that we face is that how do we structure this data? There's structured data, there's unstructured data, and then there's semi-structured data. We have to be able to have algorithms to be able to organize this data into a meaningful format. And then big data by itself is not good. I mean, not all the data that we gather is relevant to help us make decisions. In large amounts of data, there's always data that carries no relevance to the business problem that you're trying to solve. So some of the other challenges that we face are, how do we store these large petabytes or these large amounts of data? How do we store them? When data gets excessively large, right? I mean, we've had, from various experiences and maybe through the room, you could probably see that large amounts of data are very difficult to maintain. So then we get down the concept of in-memory computing with vertical and column storage. Then the other part of it is the availability of data. So if data is available, it doesn't necessarily mean that it's accessible. There are a lot of ethics that come with being able to access the data, right? And of course, how to improve the quality of decision-making with big data. So what predictive analytics does is predictive analytics, it's a concept, it's a paradigm. It allows us to storyboard all of this together. It allows us to come up with an approach to say, you know what, let's have an approach to be able to put all those big data problems together, put the technology together, and be able to tell something about our future, right? So predictive analytics, really, the definition in itself is being able to use large amounts of historical data and being able to make good fact-based decisions about the future. So you have a collection of premises, and those premises are your data, right? So in this room, I'm quite sure we have folks from different areas of the industry. I mean, majority of you may be oil and gas, you may be from public sector, you may be from agriculture. But in all of your areas, whether it's private or public sector, you know that putting the right pieces of information together can help you make better decisions, right? Better decisions not only about your supply chain processes, better decisions about where you run your investments, better decisions about where you set up your next office or where you set up your next sales and marketing office, okay? So when we talk about predictive analytics, primarily you can categorize into, I'd say, 3 different areas. You have logistics regression, and that is being able to use a lot of information to predict a single outcome, right? A single outcome could be, with all the investment that we plan to make, let's say for PetroChina in the north, what can we expect? Is it a good decision or is it a bad decision? Forecasting. So forecasting is using big data, predictive analytics for continual trends, right? To use as much of the statistics as is available to us to be able to say what are some of the outcomes we can continually predict in the next few weeks, in the next few months. Segmentation as well, and segmentation more refers to being able to categorize into, let's say, buckets of data with related attributes. So the roadmap for predictive analytics, I mean, a lot of it starts with raw data, right? And that's at the crux of the problem is there's a lot of raw data out there. I mean, we walk into companies, we have people who have information on spreadsheets, we got information on different IT systems, and we have a lot of information that just exists out there in people's heads. But one of the challenges is being able to find the right type of IT or computing solution to be able to gather that information, identify what that right information is, and be able to manage it, store it, and report off of it. So reporting is a key component of this. What does reporting do for you? Is reporting allows you to tie all the ends together. It allows you to piece the relevant pieces of information together to tell you how something is operating, how something's functioning. But predictive analytics also refers to reporting that allows you to predict future outcomes based on facts, historical facts. So, I was asked to put together an architecture diagram, a solutions architecture for big data, predictive analytics. And, typically the trend would be people would say, well, I'm assuming I'm going to see some technology in there, right? But if you take a look at this diagram for a second, you'll see that at the very top of this is human intelligence, and at the very bottom is raw data. So when we build that pyramid of human intelligence, big data, and predictive analytics, at the base and at the foundation are our informational sources. So that data has to exist, that data has to be relevant, and that data has to be clean. The next step, of course, is, sorry, it kind of sounded like the projector was burning. And the next level of that is in-memory computing. So the concept of in-memory computing has come around with the concept of big data. Databases have gotten so large that it's very difficult and very expensive to be able to process a lot of this, slowing down predictive analytics, slowing down reporting. So what a lot of vendors, including HP Vertica, have, for example, HP in partnership with other companies like SP, they have the HANA system. So what that does is it takes the entire database and it loads that into memory, right? So think about that. One of the most difficult problems that we face in the consumption of data is the speed, the velocity, as I said. So when your entire database is loaded into memory, and we're talking terabytes and petabytes, when you have hardware appliances that have those capabilities, it really improves your ability to make those decisions. Then the next step is the data modeling. You have to be able to put together the right data model, which means there has to be some sort of a logical and a physical model associated with the data for it to mean something. Column store is just how you can maintain it, and data will grow. Data will grow over years, months, and it'll continue to grow. I mean, if we were to gather all the information, let's just say that D&D in Ottawa has in public sector for our security, I mean, that information per person amounts to so much that, it's not even possible to store that. So we need to run some sort of compression algorithms. Physical and logical partitioning really refers to how you segment that data, and indexing just improves your ability to access the data. At the very top of it is your reporting with predictive analytics. So that's where you get in reporting solutions, where companies like HP Vertica, Business Objects, all these companies have different reporting solutions that allow you to use those data models to come up with fact-based assessments of what future outcomes may look like. However, at the very top of that, we can't forget what the most important premise is here. The most important premise is we have to have the ability to apply human intelligence to use all of this, right? Human intelligence meaning, yes, these systems may make our lives easier. We may sometimes not even know how all the information was generated that we've passed off to our CFO or the Minister of Health or the Minister of Defense. We may not know. He may not know how that information was generated, right? But what we have to make sure that they're aware of is the ability and the understanding to dissect that information. So as you can see, the pyramid of the architecture or the foundation of big data, predictive analytics, and human intelligence is not just about technology. It's a combination. So if we look at some of the examples out there in the industry, fine, big data, predictive analytics, but what has it done for us? Everybody's heard of Netflix. I mean, it's on the internet. It's one of the cheapest ways to actually be able to watch a movie. United States, they have their own Netflix, and we have our own. So this company basically, they executed a project where they asked engineers to be able to analyze the information from their user base in terms of what movies do people rent based on the genres and all of that sort of stuff, and analyze customer behavior and buying trends to help them predict a recommendation model. A model to say, well, you know, what should be the movie that you should be renting? So when you initially log in, that initial set of displays really reflects on what your buying trends are, or your rental trends are, okay? And that again comes by studying their customer base. Match.com, that's for any of us that don't know what that is, it's one of the world's biggest dating sites. I don't have a profile up there, by the way. So Match.com, again, similar exercise, and these are some of the findings that they had. Like one of the key things that they assessed was, you know, folks that had Twitter accounts and were in their user base actually had very limited relationships. Interestingly enough, people in the United States identifying themselves as Republicans, who we believe are far more conservatives, actually on this site were willing to reach out to Democrats. You know, that didn't have anything to do with who they were wanting to date or anything of that nature, whereas the Democrats were more reserved. So putting it all together, human intelligence, big data, in-memory computing, and predictive analytics is something that can definitely help make our lives easier. It is something, though, that when we get back to facts, we get back to the reality of the situation, not everybody's willing to invest in that. And why not? Because people have to be able to understand the relevance to their industry, to their market, right? So folks out in oil and gas, they have to understand that, why is it of benefit to me? It is of benefit to me because it's going to help me decide as to whether I need to drill a well here or not, right? What are the right conditions for drilling that well? From a transportation perspective, should I go with a company that provides oil pipelines to, you know, transfer the heavy crude, or even, well, it's heavy crude from the north all the way down to the south, like Keystone? Or should I work with transportation companies like Canadian Pacific Railway, which are very different, pipeline versus rail, but they serve the same purpose, right? So all of this information put together in predictive analytics for oil and gas can help our leadership make better decisions about where to invest. So there's some more examples courtesy of HP Vertica, and you know, they've invested very heavily in the energy sector as well. And as you can see, that some companies already have a big data program, but what they're going through is more of a transformational exercise. So some of the case studies that we have in here are energy companies from Europe. We have the next one we have here as well as Guess Jeans as well, right? So basically, for example, their Oracle-based point-of-sale system was replaced, and you know, instead of daily reports reporting from 3 hours, they're now reporting 1 to 2 minutes. And a lot of that comes from the in-memory computing capabilities that are available. So, you know, whether you're in politics or whether you're in public sector or private sector, don't get caught up in these buzzwords about, you know, big data, predictive analytics, but really think about what the business problem, or what is the problem that I'm actually trying to solve. And logically, based on my human intelligence, what are the 4 or 5 most important pieces of information that I need? And what is the additional information which, if storyboarded properly, can help us make the right decisions? So that's pretty much it from my perspective on big data, human intelligence, the evolution of human intelligence, and predictive analytics. One of the key takeaways that I would like to comment on here is, I think it's very important to continue focusing on developing the idea, the paradigm of big data, and to continue to support that as a practice, and really encourage the study of it, because there are a lot of good outcomes that can come from it. Thank you very much.
So I'd just like to thank you for a very interesting presentation. You've certainly stimulated lots of thought about how we might use human intelligence and big data and predictive analytics. So thank you very much. And I'd like to just present you with this small token of appreciation for your presentation this evening. And Perry has said that you need to open it now.
Oh, thank
so
you.
I'll let you do that.
Perry. Okay. Excellent. Thank you very much.
Oh, very nice.
Thank you.
Thank you very much for your presentation.
Thank you.
If you've already got one.
I'm just hoping I come back next year for another one. Thank you.
Join the conversation next year as more cities become data-driven. Become a community partner. Contact us at info@abctech.ca.